Hello, everyone. Welcome to a second design review for today. This is looking at machine learning for version 14.1. Okay. These changes to LLM synthesize, LLM function, and so on. Is there a design change or is it just functionality change?
Well, there's a little bit of design change in a sense because you can also add if you open the page, for example, for Chat Evaluate, you will see, or LM Synthesize, you will see an example. You can it's a very obvious design extension. Instead of just putting text in, you can add
Yeah, you put
images.
an image, right?
Exactly. So it's already supporting a list, and you scroll up, yeah, there. So the list was already supported. Now you can add this.
So it's
So I think
essentially
this is quite
concatenating the
straightforward.
image into the stream of material sent to the LLM.
Yeah, I mean, most models right now support multi-part
Yeah, I understand.
messages. So it's just adding a new element, which is tagged as image, and that's it.
Okay. Text summarize. Wait a minute.
So
We're
here
going to
I'm
talk
gonna add
about
this.
vector databases. What's that?
Yeah, here I'm gonna add. I mean, the only change here is support for vector databases. I wanted also to look into supporting a normal search index object. So one caveat here, and if you bring up the page for text summarize, it's gonna be easier to explain. We support a source argument, which is called text, and I say in the table possible form of text include. Yeah. So in general, this is the whole text. But when you give it an index like semantic search index or search index object, I think we should only support this if you give a topic specification, which is equivalent to, in this case, equivalent to like searching those indices. Because
I see. Yeah. Okay.
otherwise, it could be huge. Yeah, you don't really want to summarize the whole database. It would take forever. So I think that in general, you typically want to summarize like something in the database, which is the
Sounds okay to
advantage
me.
of having the direct hit here.
Right. I mean, it would be useful perhaps to be able to say, what is this whole thing that I've got? I've got a search index object. Tell me about it. It's a question of how one handles that, but it seems like, oh, this is a search index that has roughly this and this and this. It's kind of like a Linguistify problem for.
I was thinking about Linguistify specifically. I discussed that with Shadi today, and if we have Linguistify for files, it might work as well for the objects that have a direct representation of those files. Like, audio. We were thinking about audio and image, but this is also something that could be done here.
Right. I would think that was the place to go, but initially, having search index object arrow topic seems like a reasonable place to start with text summarize.
Okay.
All right. Semantic search is completely new, and that's a vector
Yes.
database play.
Yes. If you scroll down, there's the whole section about this actually. That I think that was wrong copy pasting on my side.
Okay. All right.
But yeah. So just to wrap up on this. So here, for image synthesizers that I would like to do, but I'm a bit unsure about how to handle this because we had this potential idea of AI evaluator.
Yeah,
but then you brought
now
up one
LLM evaluator, but I think we can call it LLM evaluator, even though, I mean, for goodness sake, people are using vision transformers and so on in image generation. I understand that it's not strictly an LLM, so to speak, but I think it's become common usage.
Okay. The only thing that I was a bit unsure about is like that idea that we floated about AI evaluator was to like be a superset of LLM evaluator and contain specific tasks. So that thing is also like needing design, because like something like semantic search, we will need like two configurations, one for embedding and one for synthesis. So yeah, that's something that we.
Well, I mean, presumably the AI evaluator gets to have an association of lots of little pieces.
So exactly, but last time you suggested not to use the AI evaluator and to use something like system services, but that doesn't seem to be a thing.
What do you mean it doesn't seem to be a thing? I mean, we're not going to build some giant structure here that is about to get
Mhm.
built somewhere else.
Okay, so I can just wait on that, and then hook on that when it's ready.
Okay. LLM synthesize submit. Is that used by our
Yeah,
own?
those are were like ideas that were like floated up for this version, but didn't make it. I just want to make sure that these are like in the plan. This is not ready yet. I mean, this thing came from interacting with Theo. It's basically a asynchronous version of LLM synthesize,
Right. I just don't know what
and
it brings
is
back. Because I
a
mean,
task
something
object,
like what's that?
a task. This is the
Okay.
classic
Okay,
submit
fine.
thing, and the kind of a challenging thing here is to support tools, which are inner tasks. So this is a nested task thing, and we have a prototype for this, but is a challenging design. We want to do it right, so we are pushing it to
Right.
the
What
next
on earth
version.
is
But this
this?
is going to be super
What
useful.
on earth is this?
Which one?
Knowledge graph. I don't know what anybody means by that. They always mean different things, and sometimes what they mean is incredibly thin.
Yeah, this is something that was brought to me by multiple people, and Joffrey has a prototype of this. It's basically kind of extracting the knowledge from an LLM and connecting things and building a graph out of that. But
Well, show me an
it was too.
example, then I will know
Yeah,
what you're talking about.
exactly. No, this is like for next version, not this version.
Okay, let's talk about neural net back end, and then let's talk about vector databases.
Okay, if you scroll down, so the main change, if you open the page target device new, that summarizes basically the changes.
Sorry, which page? Target device new?
Target device new. Yes.
Is new in
Because
all caps? Is new in all caps?
It's the same. It's the case is sensitive on Mac.
Oh, but it's capital N, lowercase e.
It doesn't matter. It is like this, but on Mac it doesn't matter.
Oh,
or
okay.
on any case insensitive file system is going to be the same. Okay, so here we are proposing like a completely new structure. Like we used to have only CPU and GPU. Now what we are proposing here is to update GPU to have a broader meaning. So GPU, and Matteo was actually suggesting to actually rename GPU. I mean, still support it, but rename it to something like accelerated, which I don't like, but I put here because I understand the reasoning behind, which is something broader that basically looks at what accelerators you have available on your machine.
Meaning that
so
you
depending
use a neural engine.
Exactly.
And
so
why
depending on
wouldn't
your
you
system
use
ID.
those?
You would, but it's just we haven't. I mean, the broader name for all these things are accelerators, GPUs, neural engines.
So I mean, my question is this: target device, presumably the default is target device error automatic. I can't see why you wouldn't want to use.
Because in general, there's much less support on those than on like you're relying on some library supporting all the operations, which is not always the case. Like CPU will always run. Those things may.
I understand, but I mean, if they can run them. If they cannot run, notice that they cannot run and run them on a CPU.
The goal would be to have automatic. We are working very hard to make sure that that's not becoming slower for testing things than actually is to.
Okay.
Well, this is the main difficulty.
Zoo of what actually happens underneath.
Right now, it's not too big. You have we are thinking about in basically two things. Like CUDA is simply explicitly stating what we always supported as GPU. And CoreML and DirectML are new. And they enable to use basically Apple hardware, which was, I mean, since Apple ditched NVIDIA, we didn't support accelerators on Apple. And DirectML, which is based on DirectX. And that means that you can also use non-CUDA compatible GPUs on Windows. There's in principle a fourth one, which is 1DNN, which is the one from Intel. But a bit unsure because from initial tests is not so performant. So if it doesn't do better than CPU.
The people at Intel about it.
Yeah.
What they think we should do. Maybe you can initiate that through partnerships.
Okay, good point. So we added a first layer of automation, so you don't have to say core ML or direct ML. I mean, you can if you want to target it, but you can say just GPU, and it will figure out what to do depending on your platform and what you have installed. Like if you have CUDA enabled cards, or if you don't, it will go to different paths. So in the current setting, target device GPU is a very portable setting that will work on any device.
Look, target device arrow accelerator doesn't make a lot of sense. Wrong part of speech.
Yeah,
the accelerator probably.
Yeah, it would be accelerator if we had that. But I think that's the future. I'm not sure if it's the right name yet.
I think GPU is a brand, and people kind of say, "Am I going to use GPU or not?"
Yeah. Okay. I see your point. Like possibly right now, still yes. Like a neural engine is not a GPU, but I don't know how many people know the difference.
Yeah. Right.
Because there are technically three
Intel
groups
SoCs. Intel SoCs are also getting the equivalent of a neural engine.
Yeah.
And that could be other things. I mean, the thing is that it's probably going to be a little bit more complicated before it gets simpler. Like instead of CUDA, it could be ROC, which is Radeon, Radeon's, language.
Yeah.
Mm-hmm. But I think, look, the way to deal with it being very complicated is either a bunch of string names or some structured association of these things. I don't think we should try to clean it because, as Roger points out, it isn't very clean. The distinctions are not clean. I have this extra GPU and I also have, onboard acceleration of some kind. How do I combine all that stuff? Blah, blah, blah. Gets very complicated.
Well, I think that I like this proposal here because basically we educated people that GPU is the accelerator, and that's still going to work, and it's simply going to do more. And those explicit names are just, if you come here and you want to look exactly what's being used. But I imagine most people just use GPU, and it will just work on more systems than before.
Well, the only issue is somebody who says, I've got a Mac, I didn't buy a GPU for it. And yet it's still going to work, which is why Automatic is really important.
Yeah.
I mean, I'm with you. We want the Automatic.
I think we should document Automatic here, which is, okay, how do I find out if I have a GPU or what we consider a GPU? Is there a dollar system capabilities or something which gives me that information? Can I even find it if I go to, here, look. This is kind of a scary thing that it probably isn't here, right? If I go to system information, right, can I find out what kind of GPUism I have?
I think you can. If you go to front end, it will list it under
front end.
Yeah, because we use it for graphics. That's what GPU stands for.
Yeah. Okay. Well. Where do I have it?
It did have. I'm sure we had it. Maybe it's.
All right. So listen. Let's figure out how we get the information about whether you have a GPU in system information or elsewhere.
Well, I'm sure we have another way because Matteo has hooked us. I need to talk to Matteo tomorrow morning, and I'm gonna figure out what he's using in neural networks. To decide,
fine, but I'm going to make the point. It should be in system information. Yeah. There should be a way to query it, and then we should use that to determine what Automatic does in this case, and we should document Automatic here.
Okay. And so let's say Automatic by default, if you have some accelerator available, it's going to use it.
Yep.
Otherwise, going to go back on CPU.
Yeah, exactly. Okay, so now another comment. In NetTrain, I would suggest that the progress monitor gives some indication about whether it's running on GPU or not, or what it's running on. See what I'm saying?
Okay, yes.
Which it doesn't right now, because the whole point is that's kind of a feedback loop. If it's like, oh my gosh, this is so slow, and you see, oh, it's running on CPU. Well, that's not right. That makes sense?
It says that. It says that right now.
Okay, fine.
It says CPU or GPU
Okay.
in the method. Okay, I don't know if it could be made more visible probably, but it says that.
Okay. Well, then we could unroll the GPU one and what it actually is of running on.
I think
What?
that will happen automatically probably with the mapping, but I can make sure
okay.
of that. Yes.
Okay. All right. Okay.
So basically, just to clarify, this new support is gonna happen. I mean, for net external object, of course, because that's using directly ONNX models, but also for layer, net chain, and graph evaluation.
Although you're saying that won't happen instantly.
Well, actually, it kind of will.
Yeah.
Okay.
Julia will explain.
Well, okay. So right now, all our layers they exist in our framework. So when we need to evaluate them, we instantiate an evaluator of the chosen backend. So instead of instantiating something with MXNet or other backends, we are going to instantiate ONNX evaluator. So this is happening already right now, and you in general you have a cost. The cost is on the first evaluation of the network. The first evaluation, that means that if you train, of course, you're going to evaluate many times, so you don't see that. For inference, it's always going to be is always being the case that the very first evaluation is creating the evaluator, so it's a bit slower, and then the subsequent evaluations they don't need to recreate the evaluator, so they are very fast.
Do we give a progress monitor that indicates that?
I think that we typically not for our backend because it was never kind of above like 2-3 seconds. We should make sure that
we should do it even for 2 seconds because people look. I've seen this and I'm like, oh my gosh, it's so slow. I can't even do it again.
Okay.
Yeah, I didn't know this point.
It's a good
even
point.
I didn't know this
point.
point. Now, another question is, can we freeze dry the thing that it is creating? What is it exactly creating?
And is it something in memory, like as a memory, like it's a blob?
Yeah, okay. Why can't we not just read it? If it's going to be the same blob, for what class of systems or machines is it the same blob? You understand what I'm saying? So for example, we had this issue with the compiler that we thought we were going to have to create different versions with different machines. Then we found out there was a slightly more portable way we could do it, blah, blah, blah. But my question is, can we cache those blobs? Particularly if it's coming from the neural net repository, why not just cache those blobs for different kinds of machines and just read them in? Do you see what I'm saying?
Yeah, I'm thinking the size is going to be a different magnitude.
Well, that's what I'm going to. I was wondering about that. Is the size much bigger than the specification of the neural net, or is it kind of this is the bitmap of the neural net? It's potentially smaller.
No, it's still the same.
Okay. Well, okay, then if once the neural net repository is capable of having the plumbing to know you're running on this very specific kind of machine, right? So it could download just the thing for that very specific kind of machine. See what I'm
saying? Sorry, I jumped. What did you say? You download the optimized binaries basically for the machine?
Yes, for that particular machine.
Okay, we can. I need to think about that, but we can do that before we can start with the more popular network and see.
Just see what happens. Right, because then we can just completely get rid of that latency.
Yes.
Right. Okay.
I mean, networks backing like system functions are the first network candidates for this, I think.
Yes. Okay, gosh, that's quite a bit here. Okay.
Okay.
Right,
no,
it's
less than you think. The vector database is the biggest part here.
Okay. So we already went through this design. Is there anything that doesn't work about this design?
I just want to make sure that you like all the names, which we didn't finish. I think that those things for databases, we were pretty happy. Roger was suggesting to be a bit more defensive in the design and call vector database object.
I think it's a good idea.
So vector database is at this point becomes vector database objects, I assume,
Yes.
the one that gives a list to them. Okay.
Yes. 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 Yes.
Mhm.
Yes. This is good. Within.
No,
Okay.
sorry, that's misspelled.
Okay. What do you mean create a new vector database? That's not the right description of semantic search.
No, that's sorry. That's I got a notebook quickly to send it to you. This is probably not the right one. Semantic search is searching through a vector database. Semantic search index is the empty one. And then create semantic search index is the one that creates that. This is copied over from create search index. I think this is what you suggested for the design.
Yep.
One thing that was floated up in one of the team meeting is that semantic search index could have a name that reflects the concept of embedding, like semantic embedding index, embedding database, or something like that. Because I mean, the real difference between this one and the vector database is that this is managing the whole embedding thing. Is having an extra layer that is doing things for you, like chunking.
I mean, my question is, if I want to know what's the embedding vector for this piece of text, how do I get to that? It's with feature extract, right?
Yes, we could also add a function. I have an internal version of that, which is text embed. If you want to do that,
What
if you want to
do
like text in, vector out.
Why isn't that feature extract?
That could be done in feature extractor.
It should be.
Feature extraction. Yeah.
Yeah, it should be.
We could add a new property there.
Yes. Why is it a new property?
Because well, can you pull up the documentation for feature extraction? I think you already have something on text.
Yeah, we do.
So it should be like a different one, ideally.
I mean,
or we.
Okay, so this works by taking in a set of examples. Is that what you're talking about here as well?
Well,
no, you have a standardized.
This is why I'm a bit uneasy about this, because this thing here is built to create like an extractor, like to train a feature extractor, sort of. It's like classify. You can get the extracted vectors as a side effect.
Okay,
but
if I
the
want
main
to use
purpose.
MFCC, for example, yes, I know this was not what I thought it should be. I mean, you know, I was told it was always irrelevant. So here you are actually getting the vectors out with
exactly
feature extract, right?
Exactly. Feature extract. Yeah, sorry. I got, even myself, even I get confused about this. Feature extract is performing the extraction. Yes.
Okay, but I thought that there was some named feature extractions that weren't based on examples, where it was just.
No, this is some design that I proposed at one point, and we need to circle back to that because we don't have a nice way to access naked extractors without examples.
Well, that's just silly.
I know.
I mean,
I agree.
Maybe we should have a function called embedding vector of, or I don't like just the word embedding on its own. It's something embedding. I mean, given that we bit the bullet and said vector database, maybe we should call it embedding vector, and then embedding vector takes as a first argument a named method for doing it, and as a second argument the actual, the data. See what I'm saying?
Well, as long as we can have an operator form.
Yeah, right.
Yeah, we can
Embedding
do either
vector
argument,
of the sort of embedder, and then of the data that you're trying to get that for. I think this makes perfect sense. I mean, that's what we're effectively doing in feature space plot when I don't even know how it works. I mean, in feature space plot has a feature extractor.
Yes, that's calling feature extraction followed by dimensionality reduction. You can, if you want to create it on your own,
Yeah, I understand.
is
But
feature extraction and dimensionality
right, but
reduction.
why are you using feature extraction when, I mean, are you giving it all the explicit examples, or are you just using a fixed feature extractor?
No, the feature extractor depends on the examples. Like if you do feature space plot of images, it's gonna use an image extractor. If you're doing feature space plot of like something else, like vectors, it may be just doing standardize or something like that.
Okay.
It's basically the same as it's the same thing as when you do classify. You know, you can throw anything at it and we'll make it and make a vector.
Don't we want the standard extractor? And we want it to be compatible with other things. Don't we need the standard extractor? I mean, or embedder. Let's say for sentences, don't we? You know, our vectors might be totally incompatible with the other vectors.
You need the method, of course.
Right.
Like, this is what I was thinking about. Like, I mean, I have the backend ready for like something like text embed, which will work similar to LLM synthesize, where you give an LLM configuration. It can be a local model or it can be an API model.
Yeah.
It will do the embedding. So that is the clear design. If you want to do something broader, we need to think carefully about this because yeah, it needs to be super reproducible and very well versioned and documented.
Sorry. What we had a whole discussion about feature extraction and different versioning for it and so on. But so now, what are you saying? You're saying embedding vector of
it's the same beast.
Yes.
And you might want to specify like in my internal function of text embedding works the same as LLM synthesize. It takes a bunch of text and an LLM evaluator. And the LLM evaluator, of course, can go to a local model if you have one, and something that it will be possible to call local LLMs. But the basic syntax is that, because you need to be able to specify what exactly you are doing, because that needs to be mirrored in other applications.
Yeah.
And the point is that once you put the vectors in the database or wherever, then whenever the vector is just a vector, it doesn't carry any information. So you need to either use something like semantic search.
We discussed at great length in when we designed feature extraction.
Yes.
And I don't completely remember how that came out. I want to look ahead on this agenda. I'm sorry. We obviously need this embedding vector thing. I mean, it really does suggest maybe that we should not be generating these naked vectors without any versioning information. And that perhaps what we should be doing is having an object that has embedding and versioning information. And if you really want just the vector out of it, you can say normal of it.
That's semantic search index, yeah? Semantic search index is exactly that, because it contains information about, each option will control how you do the embedding, the chunking and the embedding.
Okay.
So for this application, like we are covered, is more like, if you want, like in full generality, is like that. And the other one was, just want to make sure that is the right name, is like LLM prompt generator.
What the hell?
Is the last one of this list? Oh. we look at that for RAG. This is like.
Oh yes, right.
I have documentation for this. If you pull it up, there's some examples. Yeah, so this wraps a function, and you add it to prompts. So in this case, it's just this is the stupid echo, but just to show what it's doing. The one below, for example, is adding always current date time using date string, and it's preparing that to every prompt. And of course, these are just like simple examples, but you can use these to hook up semantic search and do RAG. You can hook up whatever you want basically here.
So there could be a list of prompts here, and one of them is an LLM prompt generator.
Exactly. we at the beginning, you remember that we named this like RAG tool, but then we decided
Yeah,
that this
no,
is
no, it's
really,
more
it
general.
belongs to prompts.
Yeah, it's a good idea. Okay.
Okay, so if this is approved, I'll just speed this along.
Yep.
So now, something like that came out of our internship project is this random classification data. That it's kind of like, it's minor but interesting, I think. It's like we have data generator to test pipelines in many fields. You know, like we added random color when we started to do color processing. This thing here is basically generating classification problems or clustering problems, depending on how you see that. So by default, you can specify how many examples you want, and
How do I say I want pictures of cats? Everything wants to be a picture of a cat. How do I specify that?
Well, this is like right now that this was the internship project. The first version is numerical. We can start expanding these to handle different data types at one point.
Why don't you put it in the function repository for right now?
Okay.
We'll talk about it again later.
Okay. So then for linear model fit, we are working on, I mean, the big update is going to be like formula specification that's tied to Tabula. But in the meantime, what that is being like organized, we basically revamped all the functions. So I think I showed you that in one machine learning meeting. If you open the linear model fit page, for example, you will see that the list of properties is very different now. It is much more compact. Basically, this stuff was developed before dataset. Sorry?
We won't document, but we will support the old ones.
Yeah, everything is supported. If you still use it, it will come back. So now you see if you go to the property list, you will see some of them are new. And basically each one of these is replacing like 4 or 5 properties of old.
Okay.
So it makes the list a lot more manageable. So this is the list of properties that the final big one with excise properties is the one that we don't have anymore. And it's basically because every data set was split into, you know, data set headings, the columns, rows, content, and simply because we didn't have like a table-like structure to put stuff in.
Okay, so this is now using Tabula to. No.
Right now it's using dataset also because it's sometimes not rectangular.
Yeah, it's the right
but it works, yeah. And the other update that we did on linear model, non-linear model, is that now it fully supports around.
Yeah, it's a big deal.
This is very nice, and
does it support quantities? It supports units as well, right?
Not yet, but this is we have it in line. We have data, object, and quantity. This is the list of things that you want to support around, quantity, and dates, because this was never added. And around, in the end, like supporting that on the whys, let's say the responses was quite easy. For the independent variables, there's some stuff in the literature. We just picked one implementation, which is an iterative methods to propagate uncertainties. It seems to work quite well. It's quite fast. Doesn't add much overhead. And I mean, in the end, we want to make this function modern in the sense that we will have to eat everything that is sensible to eat. And for me, this includes around, dates, and quantities.
Yes. I mean, you could imagine other things like geopositions, things like that.
We can have a richer list in the end when you kind of steer these towards like classify and predict.
Yeah. I mean, mostly you're just doing one-dimensional objects right now.
Yes, but this stuff. I mean, the point is, if I don't want to add a feature extraction option to this until we cycle back to feature extraction.
No, I agree.
And we stress because it's just propagating something that we know we want to redesign. Right. So these wrappers are kind of very obvious, and they come about when you do, real data. You will have uncertainties and things like that. So it's very nice that we don't fail anymore.
Listen, I would really like to get going if there isn't a lot more to talk about. Did we talk about decision tree previously?
No, but sorry. This is stuff is for the new version. There's that XXX new version. This is just to. I left the plan here for this. This is just to show you what.
All right. So this is what's here now.
Exactly. So
All right. Okay.
we focus mainly on semantic search and LLM stuff for this release and the
Okay.
big neural network update.
Okay. Is there anything else we should make sure to look at?
I think we covered everything.
Sounds good.
Yes.
All right. Good work. Okay.
Okay. Thank
See
you.
you all soon.
Okay.
Bye.